Hey, welcome back. Today on my bench, got something a little different. It's an Anatek. This is electronics. It's a little power supply, regulated power supply model 2520. No, it's not 2520. It's 252S. So it's regulated supply, 0 to 25 volts, 0 to 2 amps. It's a nice little unit, nice bench supply. It's very nice. I wonder what these things cost. They probably cost about $400 or $500 new. I know these weren't cheap. Yeah. So the complaint is this is a viewer submitted piece of equipment. He came to me. He says, "You know, I got this power supply and the pots are really messed up, and could you just replace the pots?" I said, "Okay, sure, bring it over, and I'll have a look at it." And he did. So let's have a look and see what it does, because I can't remember if I tried this out or not. Okay, we got a power light, and the voltage setting is quite twitchy. It's got a 10-turn pot, but look how twitchy it is. Like, you can set it and it'll settle, but it's shooting spikes of over voltage. Every time it twitches, it's shooting a spike of over voltage, so that's not very good. It's messed up all the way through. Turn this on. What have we got? About a meter says it's about 3.5 volts, and that's what that says, 3.2. So let's turn this up. Turn it up to about 10 volts. .9. Meters are fairly accurate. Let's start loading it down. Give it 1 amp. Okay. That's 1 amp, and I have no control over the current. It's like that pot is open, because it doesn't go into current limit until I force it to the end, and then it goes into current limit. So I got no control over the current. Turn it up to 2 amps. And we're at 2 amps. Same thing. No control. The voltage is still twitchy. So yes, both pots are done. So I ordered new pots. Both are 10 turn. This is a 10 turn, this one isn't. But we'll put both 10 turns on both sides, and then we'll get this thing back in order again. Let's pull the cover off, have a look. So it's a pretty basic supply. It's a linear supply. Chassis's got a good bend in it. I just have to straighten that out. Looks like it was dropped. Power transformer, and you got your series pass transistors and a heat sink, a large heat sink. It encompasses the whole thing. And a printed circuit board down there with some electrolytics and a little chip. I'm assuming that is a, what is that? Can't read, it's covered in dust. It is a Motorola MC1466, some kind of regulator chip. So here's our 2 pots we need to change out. We should have plenty of room to put our new pots in. These knobs are filthy. Might go for an ultrasonic. Maybe I'll put new knobs. It came with new knobs. Look at that. Put those new knobs on there. That would be really spiffy. Okay. And some wiring in the way here. Okay, here we go. 50K pot. Pretty simple. The gray is the wiper. I don't think they gave me enough nuts. Is this going to fit? Okay, we're good. It's got the same thread. So 2 is the wiper. What do we need to connect to here? Clockwise goes this way. Clockwise goes this way. So we need to connect to number 1 and number 2. Number 1 is this one, the middle one. Number 2 is the outside one. That's your wiper. So the gray goes to the wiper. I'm still in view. I gotta check because I make the mistake of working off the side of the camera field. I do that quite a bit. And I apologize. Alright, we can put this one back in. Ouch, that is hot. A lock washer on there. Hope we have enough for this. No, we don't. Need a little bit more. Give it max. There we go. Nice and tight. Perfect. think these knobs look a little better. Look at this Chinese quality here. The set screw fell out too. It doesn't even fit. What is going on here? Okay, look at this, guys. What do we have on this shaft? Let's do it in metric. Hang on, let's zero this. Zero. Do it in metric. It's a 1/4 inch shaft, but 6.36. What do we have in here? 6.22. For some reason it doesn't fit on the shaft. Wonder why. That's incredible. Okay, we're going to go back with the old knobs. I'm going to clean these knobs though. I'm going to give them an ultrasonic bath so they're not so filthy. Let's take this other one off. I'll go do that right now. That's a shame. I wanted to put brand new knobs on for them. Where's my Allen key? Oh, here it is. That one wasn't even tight. Okay, I'm going to give these a bath. Alright, let's do the other side. Yeah. The current potentiometer doesn't even look like it's connected there. It wasn't doing anything. And what's going on here? Well, that looks kind of dodgy. It's like somebody... wow. So yellow is my number 3. Number 3. This is not. You know what? I can just remove this from the board. I'm going to draw this out. There's a couple of connectors there. I can peel them off and take this right out. Just give me a second. So I just drew myself a little diagram of what color wire goes to which pin, and I'm just going to pull these out now. The whole board wants to go. No, we're not coming like that. We're going to go one pin at a time. There we go. Get this whole thing out, and then I can just work on it on the bench. There we go. Okay. This aside. So this was number 3. You can do it one pin at a time so that you don't get mixed up or confused. Sometimes if you cut them all 3 at the same time, you go, I can't remember which way it went. So that's why I like doing it one pin at a time. So the 2 is our center wipe. This one's our center wipe number 2. And that way you don't get mixed up, confused. And it takes you a little bit longer, but who cares? We're not doing this for time, making money. The center wipe is number 2. And some guys complain about all the time they waste doing this or the time they waste doing that. Look at the bigger picture sometimes. Alright. So we'll reinstall this and then we'll do a test. There we go. It's finished. Alright, so before we close it up, let's give it a test. Ten turns are a little ridiculous. Sometimes I wish they were like 5 turns. Everything's good. Got no weird jumps. Should be 0. We turn this up slowly. We're not getting voltage. We're not getting voltage because we got our DC amp set to 0. So let me turn this back down. Let's increase this a bit. And we can start turning this up. Turn up to 10. Actually, before we do anything else, let's set these meters. Let's set them both so they're accurate. Zero those out. Okay. All right. That's 10 volts there, and I'm reading probably about 9.7 or so. It's pretty close. It's pretty darn close. Let's turn some current up. Let's go for 1 amp. I'm hitting the current limit. There's 1 amp. Still on current limit. I'm just trying to adjust the electronic load to draw 1 amp. Okay. And it doesn't matter how much higher I turn it, it's not going to deliver until I ask for more current. And then it goes into regulation. It's actually working really nice. It's a nice power supply. It's accurate. Even for these little tiny meters, it's a nice accurate little power supply. It's smooth now. Look at those new pots on there, so it's all working. I better leave some current because it might confuse the next person. Yeah, I'm going to wrap this up. And there we go. Nice little lab unit. That's a nice supply. I like that. It's useful. 25 volts is useful. When you get supplies that are too low, then yeah, it's a little limited in what you can do, but it's a nice. All right, thanks for watching.